Maybe we'll get a lot of work done without that Lee Wynn fella here today. Such a distraction. I know you're listening. I'm recording.
Hello, Lee.
Jerry says hi. Like and subscribe.
Wow. What's that?
Jerry is talking with ghosts.
Okay, let's open up. We have two. Well, yeah, we have two that I haven't gone through the answers yet.
Oh, what did we do?
We were just talking about this. What was the first one we need to look at? Is it electric field potential? Yeah, but the lesson before that as well, we need to look at the answers, don't we?
That's the only thing together.
Is it? I don't think we looked at the answers, did we?
We had to do a Proton.
Yeah, with these two, yeah.
Wait. Which one?
This one, electric field potential. This is the one with the electron volt in it. Yeah. This one here. Okay. The first one. Convert 2.5 electron volts into joules. Jerry, please. We're starting now. Thank you. Thank you, Jerry. Okay. So how do I do that? How do I convert 2.5 EV into joules? Times E. Yes. Just thinking about that. Correct. I'm just waiting for the calculator to open. And then for the second one, 1.5 nanojoules into electron volts. Divide by E. Yeah. Calculator's not open. So while it is opening, let's have a look. Here we go. Okay, so the first one. Multiply. That's the answer for the first one. Write that down if you need to, or check if it's right, please. And now for the next one. Ten power minus 9. That's the answer for the next one. Now you should use something like, isn't that right, Joe? Yeah. We should use something like maybe mega or giga. Giga, I think, is needed, isn't it? 9.36 giga electron volts is the answer for number 2. Is that okay? Yeah. Alright, now on to the more interesting one, number 3. What is the potential energy in electron volts of a proton which is equal distance between two parallel plates, separated distance of 1 millimeter with a potential of 9 volts? So you have a plate here, this is 9 volts, this here is 1 millimeter. So the electric field strength for this one is V over D, which would be 9 over 0.001, which is that 9,000?
0001.
00. No, this is.
This is Anna.
Yeah. This is right, isn't it?
Oh.
Yeah, thank you. So the electric field strength is 9,000 newtons per coulomb. You put a particle in the middle. Its potential energy equals QED or H, whatever letter. In other words, this. If I call this H. Yeah? 0, well, that's E times 9,000 times 0.0005. This is it, yeah? Yeah. Now, is this the answer? Not quite, because I said in the question electron volts, to use this unit. This is in joules. So, to convert it into electron volts? Yeah. .5 electron volts. Oh, yeah. Now there's actually a shortcut here. The shortcut is this. Each electron will have a potential energy of 9 electron volts when they're at the top plate. This is a benefit of using the unit electron volts. It means per electron it has 1 electron volt of energy per 1 volt. So I actually know that this will start at 9. So if it started in the middle, it will be half of 9, which is 4.5. So there is a shortcut you can do in your head for this one if you want. Okay, is that one okay? Yep, continue. Right. How fast would an electron be travelling if it leaves a negative plate and strikes a positive plate, which is 2 centimeters away, potential difference of 12 volts? Okay. What's the potential? 12, is it? And is it 1 electron? Yeah, and the distance?
2 centimeters.
But I feel like the distance is not important. So the potential energy equals the kinetic energy. So 2QED over m square root. Oh, but I don't, yeah, sorry, I don't know, I just should do the other formula, sorry, yeah, which is QV equals a half v squared. So 2QV over m square root is the velocity, square root 2 times E times 12 over, is it number 1 or 3? I forget. 3. .2055 kilometers per second.
What is the next unit?
You know what's after kilo? Yeah. So you could also say this is 2.055 megameters per second.
Is it possible?
Why?
No, this is really happens, yeah. 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 No, the electrons really do travel this fast between the plates.
Yeah.
They really do.
Can it be like more than the speed of light?
No. I think for these, they kind of go around about maybe at most 0.1 c speed of light. Yeah. This is kind of the limit. Because remember, there's also the air here. The air will act as a, friction. Even though the electron is small, it still has to pass through the air. Okay. You can actually look this up. By the way, there's a little UFO you can make. I saw a video on YouTube. What you do is you take is that going to be? Come on in. I think the picture is you take two triangles like this, and it's connected up to a power supply here, and you make this from a very, very, very light material. Make it very light, and you have all the electrons move from the top plate to the bottom plate, like in this picture. The electrons move down. Okay. Oh, who's this? Hey, looking for me or them?
Sorry. I'm looking forward to you. Can I see you for 2 minutes?
Yes.
This is class. You can feel the...
Oh yes, lots of learning here, yes? What's up?
Yeah, 1 hour is
1 hour.
Start from
Just after.
1 hour.
2
2 hours.
1 hour.
Just 1 hour?
Yes, 12 to 1 or 1 to 12.
12 to 1.
12 to 1.
1 hour.
We have 2 hours for break. Unfortunately, isolation is out today, so there will be some change for hours. Fine. What's the hour?
Get up.
We can go.
No.
You can pay for me.
No.
It's good. How long has meeting is
1
at 1 hour? We can study before 1 2 hours. That's our model.
Break is 1 2 3. 1 class.
上完这节课，
You as well.
化学3点钟。
上完这节课就是他跟我们去哪个教程？
这个人化学3点钟。哎呀，我操，这课我都要好好看。我告诉我想想，我用什么拿的500升？我用咆哮德拿的高度1 500升，用的大王是拿的数是500升，
我数学和电脑没有关系。
拿的那个
我数学491，
然后拿的那个土豪战上古土豪战拿的战士500升，宇宙木是500升。
大爷骑车摔断头，
他妈在搞笑吧？
他是没有完全摔。
哦，脊椎啊，那就不要摔断了，我他妈现在这个词用的，我操！
我他妈看一个踢在手上，我他妈不是。
那个什么，那个少年包青天，少年包青天看过没？少年包青天就那个他们第一部的那个第一集那个将军不是抱着头回来吗？妈逼是抱着头，一个将军抱着头回来，然后骑了个马回到家里。
现在都没有人关于这个山，看一点也没刷，刷很久。现在都没有什么人刷，我看你刷。
Alright. As I was saying, to make the UFO at home. Make a UFO. So these two triangle plates are really, really light. If you make the voltage high enough, you'll make the electrons move down really fast. These electrons have a mass and a velocity, so they have a momentum. But the conservation momentum says these were at rest and then they fire down. So what would happen to this plate? It would recoil. Remember the question we did with the gun? When you fire the bullet, the gun moves back.
Yeah.
So when the electrons are fired down, the momentum downwards must equal the momentum upwards. So if you can make it light enough and the voltage high enough, You can have it hovering around the room. So I saw a video on YouTube of this. So I don't know. I feel the material will be very expensive to make at home because you need super light material, a super light conductor. Yeah.
So will it be dangerous?
It's only a little dangerous. It's only a little dangerous. Yeah.
Teacher, what happens if the speed is more than the electron?
It's impossible. It's impossible.
It's impossible.
Impossible.
Could be.
Maybe Flash could, but it's impossible. Impossible.
You have to strike by lightning.
Although your question sounds simple, it requires several years to explain. It's enough for me to say it is impossible. No, Einstein's physics. Yeah. It's a hard book. Okay. Next one. How long would it take for a proton to travel from a positive plate to a negative plate if the distance... Yeah, so this is really the same question, except this time I want the time. And what is different for part 5? The voltage. The voltage is different. Oh, and the distance. Okay, so if the voltage is 25, can I go back and just change the... Is it still an electron? No, it's a proton. I'll have to do it from the beginning. Okay. Proton. 1 millimeter. 25 volts. Okay. Usual story here. QV equals a half mv squared. So V equals 2QV over m square root. Right, let's just hit that in. 2QV over, what number is that proton, please? 1. Okay, this is the V. 69 kilometers per second. Now I don't want the V, I want the T. So what formula would be best to give me the T? Well, let's see. I know the U, I know the V, and I know the S. So what could give me the T? V squared? V squared equals U squared. No. Not this one. S equals. S equals. No. You could do so. I'm sure you don't have to. Well, no, you could use S equals U plus V over 2T. Don't say, oh, we did this one. This is rule 0.
Can you use A equals V over T? Because U is 0.
A equals what? Oh, yeah, but my point is I can do this. No, listen. You are finding the A in order to find the T. The point I'm making is I'm reducing my work by not bothering to find the A.
Well, it's easy.
I don't care if it's easy or hard. What I care about is how much work I have to do. So this is the quickest way to get to the answer.
But I can still use it, right?
Yes. If you don't want to listen to me, that's fine. So S equals V over 2T. So then what does T equal? It would equal 2S over V. Do I know the S? Do I know the V? Yeah, I know all of these. So let's just hit it on the calculator. 0.002 over answer. So the time is, I'm expecting a small number, 28.9 nanoseconds.
Simple.
Yes.
What happens if we use speed and distance and time? Let's try.
You know that's wrong.
Yeah, I got twice.
We had a good discussion about this yesterday as I was making coffee.
Yes.
Yes. The answer is the same answer I gave yesterday. It's all about the 2 here.
Yeah.
Yes. Did you enjoy doing it along the way? Yeah. Okay. Good. It was a reflective experience, was it? Yeah. Okay. Right. This last one is the electron fired between the two plates. This was kind of a hard one. So you have two plates. What was the speed the electron was fired at? 1000. And the angle here was a 45. And I'm looking for the voltage. And do I know this distance? 10 centimeters. That's everything, isn't it? And I tell you in the question that it just about reaches the top.
Yeah.
Isn't it everywhere? Because how much? It could be like 0.0001, 0.001.
No,
Just about.
just about is zero. The electron has no size. The electron has zero radius. So it can get as close to the plate as it wants. It's dimension free. It's only a point. It occupies no space. Has zero volume.
Really?
Mm-hmm. True.
People still have math.
Still has mass, yeah. Quite interesting. Quite interesting. Okay, so we need to look at this as a UVATS problem in the vertical direction. Vertically. Okay. What's the U? 1000 sine 45, which is 1 over root 2. The V, we do. It's 0. The A we don't know, but Newton tells us it's F over M. Newton tells us this. The T we don't know, and the S we do know. Now Newton says it's F over M, but our formula, what's our formula for F? F equals QE, isn't it? QE over M. Okay, what's our formula for E? V over D. So this is QV over MD. Actually, do I even need the A? No, because if I don't use the A, I already have 3 things.
Yep.
Oh, yeah, no, this is right, What I'll do is I'll find the A using UVATS, like you said, and then make that equal to that, and then, so what was I looking for? The voltage. Yeah, so I'll do it this way. Okay, what formula gives me the A here? V squared equals 1, 2, 3, 4, 5, 6 over 2. V squared equals U squared plus 2 A S. So I can rewrite this to get the V here. Let's see. What is this? This is a million, isn't it? So that's 500,000 with a minus over 0.1 times 2 over E times ME times 0.1. I just took this to the left, and then the MD went up, the Q went down, and 0.1 went down, and I just kept the V by itself, which is what I want. So if I hit this in on the calculator, yeah? Did I not bring it down? Oh, I did. Sorry, that's on the wrong. Should be down here, shouldn't it? Thank you. Oh, and I made a mistake with my sign. This is not a plus. This is a minus, because the acceleration is downwards. That's good because it means it cancels this minus here. Okay, I think that's right now, Monica, yeah. Well, we'll see if we get the same answer. On the top, I have 500,000 times 3, is it? What did you get? No, what did you get? 1.42 microvolts. So good job, Monica. Did anybody get that as well? No? You said potential energy equals kinetic energy, yeah? But the mistake is on the top it has potential and kinetic. Yeah? On the ground it has kinetic, agreed? On the top plate it has potential and kinetic. Right?
How?
What do you mean how? Has it stopped moving when it reaches the top? So it has kinetic. Yeah. Okay, got that? Yeah, we'll look at the next lesson now from yesterday as well. We did them all, these questions. Yeah, the next topic I'm going to do now. The one we did, what was it? Magnets.
Yeah.
Oh, we didn't finish the lesson yesterday. Oh, so I need to go to the lesson before this, is it? Okay. In class? I thought I had 2 lessons to review. Okay, in other words, which lesson did I not do the answers for yet? Did I not do the answers for electric field strength? Okay, let's look at that. So. Did I?
No, we did. No, you started, we were gonna do the first one and then next one, but we didn't do the next last one, so we only...
Yeah, no, I remember I did the answers for these.
We did.
Yeah, because I remember the last one was 45 volts. And I would have done it for the first one and the third one.
Yeah, we have to do that one, but we're not finished the last
Ah, okay, so I'll continue with this lesson then.
one. So right now,
Yes, this one, yes.